This is topic 12-3, solving systems of equations by graphing. Our objective today is I can solve systems of equation by graphing using a calculator. So our essential question is going to be, how can I solve systems of equations by graphing using a calculator? Our bellwether problem today is a review problem. What is the equation of a line that has a slope of -4/3 passing through the point -9, 12? If the slope is -4/3, then we know that the number in front of the x must be -4/3 when we write our equation in slope-intercept form. Knowing that, looking at f, we see that -4/3 does not have the x with it, so f is not possible. In g, we have a -3/4 in front of the x, and so that is not correct. So now we are left with -4/3 x minus 16 for h, and j is y is -4/3 x. So now we must figure out which one of these is correct. We have an x and we have a y given for a point, so we can use our slope-intercept form, y equals mx plus b, and solve for b. Y is 12, m is equal to -4/3, times x is -9, and then plus b. We're left with 12 equals to -4/3 times -9 is a positive 12, plus b, and I'm writing my b as a capital so it didn't look like a 6. So if we subtract 12 from both sides, we are left that b is equal to 0. So our equation then is going to be j. J has an y-intercept of 0. So let's review. What do we know about solutions to systems of equations? What we know is that a system of equations is two or more equations. The other thing we know is that these systems can have one solution, no solutions, or infinitely many solutions. One solution is when they have one intersecting point, no solutions when we have parallel lines, and infinitely many is when we have the exact same line, one on top of each other. The solution to a system of linear equations is where the graph of the lines intersect. Sometimes we say where they cross, but it's where they are touching. So today we are going to be solving equations by graphing, but we're going to use our calculator. First, let's solve the equation using our graph here. So our first equation, y equals -2x minus 1. We know that the slope is -2 and the y-intercept is -1. So our beginning point is going to be at 0, -1. With a slope of -2, we'll put a 1 over it, so we know the top number is how far we go down, bottom number is how far we go to the right. From our beginning point, we're going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. We're going to fill in our entire graph, so we'll go back to the beginning point and do the opposite. Up 2 to the left 1, up 2 to the left 1. So we continue to follow the pattern. This gives us our first equation, or our first line. So this is our first line, y equals -2 minus 1. Our second line, y equals -x plus 3. Our slope in this one is a -1. We'll put that over 1. And our y-intercept is a positive 3, so that's the point 0, 3. Let's start off at 0, 3 on the y-axis, and now we'll go down 1 to the right 1. And then up 1 to the left 1 in order to complete our graph. As we connect those dots, we can now see the point where they both have the same point in common. And this point is when x is 1, 2, 3, 4 to the left, so that's a -4. And then 1, 2, 3, 4, 5, 6, 7 up, so it's a positive 7. So our solution is -4, 7. That is the point that is in both lines. But Now we want to see how can the calculator help us out. Calculator can help us out because we have our equations in y equal. So that means our first equation, we're going to put in y1, and our second equation, we're going to put in y2 on the calculator. y1, we're going to type in negative 2x minus 1. y2, we'll type in negative x plus 3. When we graph, we should see a graph very similar or exactly like the one we just drew. Let's check it out. This is our first graph being drawn, and then there's our second graph. And sure enough, we can see where these two lines intersect. And now we're going to use the calculator in order to find that intersection. So let's write down our steps so far. First, we input our equations into y1 and y2. Next, we're going to hit the second button and then the trace button. When you look at the trace button, right above it, you'll see the word calc, and that's what we're trying to get to. So we hit our second button. Notice the arrow saying I'm going to go above whatever trace is, and that's calc. And now we're going to choose number 5 for intersect. Because we are telling it we want to find the intersection. So we'll hit number 5. Notice when you hit number 5, it now asks what's your first curve. We'll look up and see y1. That's the first curve that we entered, and we'll press enter. It's saying, yes, that is my first curve. So press enter. Now it's asking second curve. We'll see y2, given our equation that we put in for y2. Yes, that's our second curve. So we'll press enter, saying that we do accept it. And then the last one is asking, what is our guess? Our guess, ideally we could move our cursor up to the point where it's intersecting, but you actually don't have to. You can press enter because the calculator will get to that point. Now the calculator will tell us the intersection is where x equals negative 4 and y equals positive 7. That gives us our solution. So again, we input our equations into y1 and y2. We hit the second button, then trace button, and then number 5 for intersect. Then we enter, 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 and that will give us our answer. Problem number 2. Let's see how this can help us. We want to write the equation of each line and then find the solution of the system. Our lines that are given now are on the graph. And so this is line AB. It has a point and a point. And to get the equation of the line AB, we want the equation of line AB. We need to know the slope as well as the y-intercept of that line. So let's look at AB and see if we can figure out the slope. We see that it is an increasing slope, so it is going to be positive. And then we're going to draw a little arrow, and notice we have to go up 2 and then to the right 1, 2, 3, 4, 5. So our slope is 2 over 5. We can also look at our graph and see where the y-intercept is. The y-intercept is at negative 2. So our equation for AB is going to be 2/5 x minus 2. Our equation for BC, we need the same thing. We need to know what is the slope and what is the y-intercept. So looking at DC, we're going to get, we see that our slope is decreasing, so we know it's negative. We'll connect our 2 points and count. To get to it, we have to go down 2. That's where our negative comes from. And then to the right, 4. This reduces to a negative 1/2. Our y-intercept is where it crosses the y-axis. That is at a positive 7. So our equation for DC is y equals a negative 1/2 x plus 7. Let's use our graph to see if we can come up with the solution. For AB, if I continue to follow the pattern of the slope of 2/5, I can continue to draw my line. So from B, we're going to go up 2 and to the right 5. 1, 2, 3, 4, 5. We got a point. Up 2 to the right 5. 1, 2, 3, 4, 5. We got a point. And we can extend this line. For DC, we can continue to use the slope of down 1 to the right 2, 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 down 1 to the right 2. And sure enough, we find our intersection is at 10, 2. Now let's use our calculator and check. Now that we came up with the equations, we can put our line for AB in Y1 and our line for DC in Y2. So AB is 2/5 as the slope. We'll do 2 divided by 5 in parentheses times x minus 2. For DC, in parentheses, we have a -1 divided by 2. Close the parenthesis times x plus 7. Again, we want to graph. We'll see it does look like our graph. We can actually see an intersection, but let's calculate. So we'll do second trace, number 5, enter 3 times. 1, 2, 3, and our intersection is 10, 2. For our last 2 problems, we're going to just use the calculator itself. First thing we need to do is get our equations in y equal form. So take the top equation, 2x minus y equals 3. We want to solve for y, so we want y by itself. So we want y equals blank x plus blank. We'll see the 3 is already on the right side, so it drops down. The 2x needs to move to the other side, so the number in front of the x becomes negative. And I have a -1 in front of the y, so I'm dividing by -1. So our first equation for y1 is going to be a positive 2x, and then 3 divided by -1 is a -3. Our second equation, x plus 2y equals 4. Again, box in our y. We want y equals blank x plus blank. The 4 is already on the same side, so it drops down. The number in front of the x is 1, but now we move it to the other side, so it becomes a -1. And then 2 is in the box, so we divide by 2. So our second equation is -1/2 x plus 2. We're now going to graph that on our calculator. Clear out our previous equation. Type in our new one. Y1 is 2x minus 3. And y2 is a -1/2 x plus 2. We'll hit our graph button. You can see our intersection somewhere in the top quadrant. And then we will hit second trace, number 5, enter 3 times. Our intersection is at 2, 1. Let's graph and see if we come up with that. Our first equation, the slope is 2, the y-intercept is -3. So we'll go down to -3 on the y-axis, and then up 2 over 1. And down 2 to the left 1. That's our y1. y2 has a y-intercept of a positive 2 and a slope of a -1/2. So it's down 2 over 1. And automatically I can see my point is 2, 1 where they intersect. Let's look at our last problem. Again, the first thing we need to do is get them into y equal form. So x minus 3y equals 6. We want it y equals blank x plus blank. That's our slope-intercept form. Box the number with the variable y, including its coefficient. The 6 is already on the right side, so we drop it down. The 1 in front of the x moves to the other side, so it becomes a -1, and the number in the box is -3. We're dividing everything by -3. So y1 is a positive 1/3. When I put -1 divided by -3 in the calculator, it gives me a positive. So positive 1/3 minus 2. Our slope is 1/3, and our y-intercept is a -2. Our second equation, we have 2x minus 6y equals a -6. Again, we want y equals blank x plus blank. -6 is already on the right side, so I drop it to the blank. Let's box in the variable of the y variable with the coefficient. The 2 moves to the other side, becomes a -2. The -6 in the box, everything is being divided by -6, so I put that underneath. We get y by itself, so our equation becomes y equals -2 over -6, that is a positive 1/3, times x, and then -6 divided by -6 is a positive 1. This has a slope of 1/3 and a y-intercept of 1. So let's graph. We have our starting point, -2 for our first equation, and the slope is 1/3. We're down 1 to the left 3. Our second equation starts off at y is equal to 1. Then our slope is 1/3 again. And so we know, since we have the same slope, or some of you may recognize, that these lines are parallel and will not touch each other. And so our answer to this one is there is no solution. Since they don't cross, there's no solution. Let's check on our calculator. By 1, we want a 1/3, 1 divided by 3, x minus 2, y2, we want 1/3, so 1 divided by 3, x plus 1. Let's see, when we graph, we should get 2 parallel lines. Sure enough, it matches. So now let's fill out our summary. So how can I solve systems of equations by graphing using a calculator? We had to input the equations into y1 and y2. Then we hit the second button, trace, number 5 for intersect. Then we hit enter 3 times. So enter, enter, enter. And the solution is the x value and the y value given, written as a point. This concludes topic 12-3.